Hi everyone, welcome to the video for Unit 4 Worksheet C. Now I'm going to try and make this video a lot shorter than the previous one. The last one was like a half-hour long, so hopefully this one, what we're doing today isn't really, well, I don't think it's nearly as hard as the previous stuff, so this should be a bit quicker. So first thing, I got an email from a student in one of my classes, and she was asking about number 11 and number 14 from the 4B worksheet. So I just wanted to go through these real quick and just explain how to do these. So number 11 on worksheet 4B. It's set up like this at the beginning, and when we look at this problem, the right side is just tangent of x, so there's not really much to do there. On the left side, we have a bunch of stuff going on. Well, the very first step is, I think, probably the hardest step to recognize. On top, we have sine cubed plus sine of x times cosine squared of x. Both of those things on top, there's two things there. Both of them have a sign in them, so we're going to factor that sign out, and you'll end up with this. Now, if you don't recognize the sine squared of x plus cosine squared of x, once again, that comes from our Pythagorean identity. So these two added together equals 1, so we're just going to replace that with a 1. And so we're just going to get sine of x times 1 on top, divided by cosine of x, and sine of x over cosine of x is the same exact thing as tangent, so we just put a check mark and write QED. So that's how you do that one. The next one's kind of tricky. Number 14, there's some negatives inside the parentheses, so we're going to look at our odd identities, and the only one that's really going to work for us is the sine one up top. So if there's a negative x inside, you just pull the sign or the negative out front. So we can only do that for the bottom. We can't really do that for the top. So we do that one step. And then to simplify things, I said u equals sine of x. And the reason I did that is just, you're going to see it's going to get a lot less complicated. So I replace all the sine of x's with u's. Now, the one on top of that fraction gets a little more interesting because it's squared. And there's a negative inside the parentheses, so we call that 1 minus negative u, all that in parentheses, squared. So this is what we end up with. To simplify this, I multiply both sides by 1 plus u. I end up with this. And on the right side, that's going to be, those are conjugates, so the middle term is going to cancel off. And we're going to end up with 1 minus u squared. On the right side, negative u squared is just u, so we get 1 minus u squared. So 1 minus u squared equals 1 minus u squared, so those two equal each other, so we write that's done. I did not re-replace the u with the sine of x, but you can if you want. You get 1 minus sine squared of x on both sides, so it'd be pretty easy. All right, so that is worksheet 4B. If you guys have any other questions on that, I'll be happy to address those in upcoming videos or just email you directly with pictures or an explanation. But those were for a student who emailed me. Okay, so let's look at worksheet C. This worksheet is a lot easier. I mean, there's some tricks to it, but it's a lot easier than worksheet 4B, I think. Okay, so once again, the format of this is they give you, there's like 5 example problems and then some you try them problems next to them. I'm going to do all the examples and then give you some time to try them. And then the back side of the sheet is just some practice. Now, I didn't realize this when I was making the past 2 videos, but I realized some of you guys might have left your stuff at school. None of you seem to use your lockers, so you probably have it at home. But if you don't, feel free to write this out on a piece of paper, or if you have a printer, print it out. I put all the blank copies in the drive, so if you want to download those from Schoology and then print them, you can. Or if you just want to handwrite them, that's cool too. So no matter. All right. So looking at number 1, we have, and then also on this sheet, we're going to be using the sum and difference identities, which is on our sheet. It even says chapter 6.3. This is not 6, this is chapter 4. 4.3 worksheet C. And then underneath that, we are going to be using a bit of the co-function identities. These ones are pretty straightforward, but we'll talk about those here in a minute. All right, so for number 1, we have cosine of 75, and it says find the exact value. So once again, we are not going to have any decimals at the end of this. We're not going to have any approximations. We're going to have something that is exact. And it says to use the sum identity. So looking at our sheet, these are going to be the ones that are adding. So this one is cosine of 75. So we're going to be looking for two things that add up to 75. Okay? So the way I pick the numbers to add up to 75 is I want numbers that are on the unit circle because those have exact values. So I look at my unit circle and I find that 30 and 45 are both on there. They add up to 75. So this is going to be easy. Now, some angles will not come from the unit circle. So if this was like 76 degrees, there's no two angles on the unit circle that we use a lot. They're going to add up to 76. So you can't do this for everything, but the ones that they're going to give you are always going to be angles that you can either add or subtract from the unit circle. So 30 and 45 are what we're going to use for this. So I come to my sum and difference sheet. I got cosine of alpha plus beta equals all that stuff. In this case, we're going to say alpha is 30, beta is 45. So if I do that, it's kind of just a recipe. Just plug them in where they go. So we get all that stuff on the right, and the left side, instead of being cosine of 75, I said it was cosine of 30 plus 45. So we're breaking it into two parts so that we can use this formula. Okay, from here, we're just going to look on our unit circle. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2, and then so on and so forth. So we get these, and we're just going to multiply these fractions with each other. So we get square root of 6 over 4 minus square root of 2 over 4. And then at the end, both of the bottoms on those are the same, so we can just subtract the top. So you get square root of 6 minus square root of 2 on top of a 4. And that is an exact form. We don't have any radicals on the bottom, so we're all done here. So we give it a circle and say done. We don't write QED on these because we didn't really prove anything. We just simplified an expression, so this really wasn't too bad. Okay, and as you see, the square root of 6 and square root of 2 over 4, those are going to come up again and again. They'll just be different variations of it. I think you'll see what I mean on the next couple of problems. Okay, so if you'd like, go ahead and try sine of 105. You're going to think of two numbers that add up to 105 that come from the unit circle, and then just plug them into a formula and get your answer. So if you want to pause it here and give it a try, feel free. Okay, so let's see how you did. 105 can be made from 45 and 60. Now, if you have a different set of numbers, you'll end up with the same answer at the end. And if you switch these, if you did 60 plus 45 instead of 45 plus 60, those are the same thing, so it'll work out just the same. All right, so I'm going to come to my sum formula, sine of alpha plus beta. In this case, we got 45 plus 60, so those are going to plug in for the alpha and beta. So you get this. So looking at the unit circle, we get these. Once again, multiply tops, multiply bottoms. You end up with this. And now we just add the tops, keep the bottom the same, and you end up with this. So this is really, really similar to our previous answer, but like I said, it's slightly different. Okay? All right, so let's look at example 2. Now, example 2 says we need to use a difference. So if you look at the sheet of all the different formulas, some are going to be subtractions. So that's what we're trying to do here. Now, the other thing that's kind of cool in this one is it's in radians. So not only can you have these in degrees, but you can also do them in radians. Now, we have pi over 12, which is 1/12 of pi. So if you think about it, it's your top half of your unit circle cut up into 12 bits. So this one's definitely going to be a subtraction one. You couldn't do this one by addition. So pi over 12, or 1/12, is made from doing 1/3 of a pi minus 1/4 of a pi. Now, if you don't believe me, just make the bottoms of both of those 12. So you'll have 4 pi over 12 minus 3 pi over 12. 4 pi's minus 3 pi's is just a single pi over 12, which is how I got that. Okay, so some fraction work there for you. So now we come over here. We're going to use cosine of alpha minus beta. And so we just plug our alpha and beta into here. Now, on this one, order does matter because it's subtraction. So you have to have pi over 3 first because that's bigger than the pi over 4. If you didn't, you would get some negative stuff and it would be a mess. So don't do that. So if you plug them in, this is what you end up with. We look at our unit circle, or in my case, what I did is I went on to Google Images and I searched for unit circle chart, and it gives you this. So this is really, really quick and easy to use. But if you like using a unit circle, that's cool too. So this is what I get for all of those. Multiply tops and bottoms, we get that. Add the tops and put it over 4, so we get square root of 2 plus square root of 6 over 4. And that's our answer. Okay. So go ahead and try to be on your own if you'd like. Once again, you're going to use a difference. Now, I realize that 75 can be made up of 30 plus 45, but they want you to use a difference on this one. So try and use a difference formula. So think of two numbers that subtract to make 75, and you'll go from there. Okay? All right. I hope you did well on that. So let's see how you did. 75 can be made up of, I screwed up and I said 105 minus 30, but 105 is not on the unit circle, so I had to fix that. So I got 135 minus 60. That subtracts to make 75, so we're good to go. So we plug it into our difference formula, and we end up with this. I look at my chart for all these values, and I end up with this. Multiply tops, multiply the bottoms, you end up with this. Now, this one is interesting because the cosine of 135 gives you negative square root of 2 over 2. So we have to keep that negative going. So the negative square root of 2 times positive square root of 3 gives us negative square root of 6. The negative and negative both turn into positives. So once again, we're going to add the tops and keep the bottoms the same, and you end up with this. Okay, and this looks real similar to our previous answer. So that's what we get. All right. So now let's talk about example 3. Example 3 is kind of an extension on those previous problems. Basically, at the beginning of it, they can say, hey, use a cofunction identity to come up with the exact value. We're going to use the cofunction stuff, but then it's going to look really similar to what we were just doing. So let me show you what I mean. So for the first one, we have sine of 5 pi over 12. Well, we come down here, and right in the middle, we have cosine of pi over 2 minus u equals sine of u. Well, in this case, we had sine of 5 pi over 12, so that's what our u is going to be for this one. So we come back here, and we say that cosine of pi over 2 minus that u, and we're going to take that 5 pi over 12 and stick it in for the u. So it just moves over there, and then we're just going to subtract it. So to subtract those, you have to have a common denominator. So I multiplied the left fraction by 6's, and I get 6 pi over 12. 6 pi minus 5 pi is just a single pi over 12. So we have cosine of pi over 12. Now, if that problem looks very familiar, it's because we just did it. It says to do this in the exact formula. So we come over here, cosine of pi over 12. We just did this whole thing. This was example 2. And we found out at the very end we got pi over 2 plus pi over 6 over 4. So we're just going to say, hey, I already did all this work from example 2, and this is what I got. On the test, I'm probably not going to give you a problem that you've already done for these, so you're going to have to work it all out like we did on example 2. But the only thing that would be different is the beginning of the problem where you would be using that cofunction stuff. Okay, so we already did cosine of pi over 12. So that's why I'm not redoing it here, because it would be redundant. Okay? So if you want to give cosine of 15 a try, feel free. You're going to use a cofunction identity at the beginning, so look for cosine of u, and in this case, u is going to be 15 degrees. All right? I'll see you as soon as you're done. All right, so let's talk about cosine of 15. Now, 15 degrees, this is in degrees, and if you look at all of your cofunction identities, they're all in radians. So that's going to be an issue, and we'll address it here in a minute. So the u in this case is the 15 degrees. So we find cosine of u on that sheet, and we use that, and it's going to give us sine of parentheses pi divided by 2 minus our u, and in this case our u is 15. So we plug the 15 in there. And now, since it's pi over 2, we can't use pi over 2 because that's in radians. The degrees is in degrees. So we have to switch pi over 2 to what it actually is. And half a circle is 180 degrees. So we switch that pi over 2 for 180 degrees. We subtract them. You end up with sine of 165. Well, sine of 165, that isn't on any of the other problems we did. So we're going to have to use a sum identity, or think of two angles on the unit circle that add up to 165. Now there's a couple possibilities for this. The one I'm going to use is going to be 135 and 30. So I go on to my my sum identities up top and look for a sign, and I plug in 135 and 30, and this is what you end up with. So now I'm going to look up each of these angles individually on the chart, and this is what you end up with. So now we're going to multiply the tops and the bottoms, and we're going to end up with that. The interesting thing about this is cosine of 135 does give you that negative square root of 2 over 2. So there is a negative involved, so that's the only slight trick to it. So we end up with the square root of 6 minus the square root of 2 over 4. And there we go. All right, so let's talk about example 4. And now this one says find the exact value of the following. And they really don't give you any directions. So they don't say use a sum. They don't say use a difference. So you really, you're left with any choice that you like. Now, 195 could be made from subtraction or addition. I decided to use addition, so I found that 135 plus 60 was 195. So I went and looked at my sum identity for sine. I plugged in 135 and 16 for those, and this is what you end up with. You look on the chart, find all these values, multiply tops and bottoms, and then add them up because the bottoms are already the same, and you end up with this. So this problem is really straightforward. You know, it shouldn't be anything new on that one. Okay, if you want to try 4B on your own, go ahead and give it a shot. This is really good practice, okay? So give it a shot. Okay, you're back. So now I'm going to use, for 75, we've done this a couple times already, but 75 can be made up from 30 and 45. So I'm going to plug in 30, 45, and I'm going to use a sum identity for this. So I look for my sum identity on my sheets. We're going to plug in 30 for alpha and 45 for beta. So you end up with this when you plug them all in. You look on your chart for the values of each of these. You end up with those. Multiply tops and bottoms, and you end up with something pretty familiar. We got the square root of 6 minus, or square root of 6 minus the square root of 2, all divided by 4. So once again, nothing really new added on this problem. They just give you a bit of freedom in choosing what you want to use on this. Okay. All right, let's look at example 5a. Now, example 5a, they involve us in tangents. So the tangents on these are going to be have a bit of a twist on the formula. It's not as similar. It's not that similar to the other one. So let me show you what you got. So for this one, we have tangent of pi over 12. Once again, we did pi over 12 already, and we said that that can be made up from the square root of, or I'm sorry, pi divided by 3 minus pi divided by 4. And once again, there's the work for that. So I'm going to use a difference one. I can't really think of one that you could do using a sum unless you went negative. And we want to avoid that as much as possible. So we're going to use those two numbers. So pi over 3 for alpha and pi over 4 for beta. This is what you get when you plug it in. So, pretty straightforward. We just plug them in this way. Now, since it is subtraction, the order here matters a great deal. So please don't mix the order of these because you would get something different at the end. Okay, so now when we reduce this, it is going to be a bit more sophisticated algebra, but nothing too hard. We look up the formulas for tangent off the chart, and we end up with the square root of 3 minus 1 over 1 plus square root of 3 times 1. So don't forget those are multiplying on bottom. So that reduces to this. And now we can't have a radical at the bottom of our answer, so we are going to have to multiply the bottom by its conjugate, so 1 minus the square root of 3 times 1 plus square root of 3. So what will happen when we do that, we FOIL all this out, and on the bottom we're going to get 1 minus the square root of 3, and the reason I got that was square root of 3 times square root of 3 is going to turn into square root of 9. Square root of 9 is a 3, and it does have a negative on front, so that's how we got that. Up top, that's going to turn into kind of a mess. We end up with this, and now the square roots of 3 are going to combine because there's 2 of them, so you have 2 square roots of 3, and then negative 3 and negative 1 make negative 4. On the bottom, we have negative 2. You could leave your answer like this, but it's not reduced all the way, so I don't know, you want to reduce it a bit more. So we divide each of those things on top by the square root of, the negative 2 separately. So the 2's cancel out on the first one. We're left with just the negative square root of 3. The negative 4 over negative 2 turns into a positive 2. And this is our answer. Okay. So go ahead and try tangent of 75 degrees on your own if you'd like. I think you're going to use the sum on this unless you're really, really hell-bent on using the difference one. But go ahead and give this a shot and pause the video here. All right, so 75 can be made up from 45 and 30, and I think that's what I used. I did. So I'm going to take those and plug them in for alpha and beta in this formula. Once again, order does not matter because they're summing. So if we sum those together, if we plug those in, we end up with this. Look at our chart, and we end up with these numbers in here. Now, this is going to get a bit more involved because we got some nasty fractions. But this is what we have. Multiply that 1 times the square root of 3 over 3 on bottom, and we'll end up with this over to the right here. And now those 1s I'm going to turn into something more useful so I can combine them with those fractions. So I'm going to call that 1 on top 3 over 3 and the 1 on bottom 3 over 3. So you end up with this. And now I'm going to add the tops and subtract the bottoms. So you end up with this. Now this is gross, but the nice thing about this is we have fraction over fraction, so we can do keep, change, flip. So I'm going to keep the top fraction, flip the bottom fraction over, and change it to multiplication. So this is what you end up with. Now the 3's are going to cancel off diagonally, and then we're going to end up with this. Now the only problem with this now is we have a radical on the bottom, so we're just going to multiply by the conjugate here of the bottom, so 3 plus the square root of 3. On the bottom, this is going to work out to be a real nice answer. We're just going to end up with 9 minus 3 because square root of 3 times square root of 3 is 3. And the minus sign gets preserved, so that comes along. Up top, that's going to be a bit uglier, but this is what you end up with. So now from here, we're just going to reduce best we can. So we're going to get 12 on top with 6 root 3. And on the bottom, we have just a 6. Just like the previous problem, we can reduce this a bit more because both of those are divisible by the 6 on bottom. So 6 root 3 divided by 6, 6 is going to cancel off. 12 divided by 6 is a 2, so we get root 3 plus 6, and that's our answer. Okay, so once again, this used a ton of paper for me because I'm showing all of my work and I'm writing with the Sharpie. So this is all the paper I use. So if you're using a lot of paper, you should be, so don't feel bad about that. Looking at the rest of this worksheet, for the first one, it says just use a cofunction identity to fill in the blank. So for the first one, it said sine of 20. Well, that's going to be the same thing as that pi over 2, which we said was 180 degrees because this one's in degrees. So 180 degrees minus 20. So that first one's going to be cosine of 160. So these ones are real easy. You're just going to go through there and sort those out. When you get to 7 through 12, it says find the exact value of the expressions. Well, this is super simple. They already broke it up for you. So for the first one, they already told you what alpha and beta are. All of these, they tell you what alpha and beta are. So all you have to do is plug them into the formulas and then just use a unit circle and come up with the answer. And they're all probably going to be some variation of square root of 6 and square root of 2 on top and then a 4 on the bottom, except for 11 and 12. And 11 and 12 will be those goofy tangent ones. So I don't know. These are easier than what we were just doing, so I don't know why they made these so simple. Okay, and then down at the bottom, we got a couple more. Oh, God, these ones are real tough. I'll probably go over these for the worksheet or for Unit D, just because these are real complex. These are the ones where you're using all your identities to try and make both sides look the same. So, yeah, you're going to go through these, and they're going to be tough, okay? Just to let you know. All right, that's it for worksheet C. We'll be doing worksheet D and E next week. I'll probably assign a quiz somehow. I don't know how I'm going to do that yet, but I'll figure that out before then. And I will, at the very latest, talk to you guys next. Well, I'll make a new video by next Monday for worksheet D. Okay? So keep plugging away. Don't spend too much time on these, but, you know, do them until they're done. Okay? I will talk to you guys later. Have a lovely day, and make sure you wash your hands. Talk to you later.